I'm going to solve statistics section 3.2 inshallah, so let's begin. This quiz is about permutations, since combinations is not included in the final exam. So it says in part A, in how many different ways can the gifts be distributed to 9 lottery winners? So we do 9 permutation 9, which is equal to 9 factorial, which is equal to 362,880. Now it says, in how many different ways can 3 lottery winners be awarded gifts if each one gets only one gift? So 9, which is the total, permutation 3, the 3 lottery winners. So you do 9 permutation 3, we should get 504. A theater has a vacant row of 10 seats. In how many ways can 4 people be seated in this row? So we do 10 permutation 4. So we do 10 permutation 4, you should get 5040. In how many ways can 4 people be seated in this row if the 6 empty seats are side by side next to each other? So we need to seat 4 people, so we do 4 factorial. So this is 1 person, 2 person, 3 person, 4 person, 1, 2, 3, 4, 5, 6 empty seats. We have 1 person, 2 person, 3 person, 1, 2, 3, 4, 5, 6, 1 person. We have 1 person, 1 person, 1, 2, 3, 4, 5, 6, 1 person, 1 person. We have 1 person, 1, 2, 3, 4, 5, 6, 1 person, 1 person, 1 person. We have space 1, 2, 3, 4, 5, 6, 1 person, 1 person, 1 person, 1 person. But this takes so much time in the exam, so you can skip all of this. 4 people, 3 people, 2 people, 1 people, 0 people. So there's 1, 2, 3, 4, 5. So you multiply by 5. So you do 4 factorial times 5. You should get 120. From the 8-letter word triangle, how many arrangements can be made of 5 letters? So we do 8 permutation 5. 8 permutation 5, you should get 6720. And here, since there's no repeating letters, we don't need to divide by anything. So now they want 5 letters beginning with G and ending with N. So it's G, 1, 2, 3, 4, 5, and since they specified that it begins with G and ends with N, we cannot switch them, so we don't multiply by 2, and they're fixed, so we don't include them. So we do 8 minus 2, the fixed ones, we get 6. 5 minus 2, we get 3. 6 permutation 3. That's it. We get 120. Here they want 5 letters in which T and L appear side by side. T, L, 1, 2, 3, 4, 5. These two are fixed, so it becomes 6 permutation 3 times 2, since T and L can be switched, times the position. It can also be in different positions, so it can be 1, 2, 3. I usually do this so I can see 3 circles and I add the first one, so 1, 2, 3 and 4, so I times 4. So I do 6 permutation 3 times 2 times 4, you should get 960. A librarian received a set of 10 new books of different types. She wants to place 6 books next to one another on a shelf. What is the total number of arrangements of 6 books chosen from the 10 books? We do 10 permutation 6. 10 permutation 6. You should get 151,200. Now they said one of the comic One of the books is a comic book and the other one is a fantasy book. What is the total number of arrangements of 6 books chosen from 10 books in which the comic book is at one end and the fantasy book is at the other end? So we have C, 1, 2, 3, 4, 5, 6. They did not mention what end the comic is at and which end the fantasy is at. So we do 2 times. And since these 2 letters are fixed, we should do 10 minus 2 books, which is 8. Permutation 6 minus 2, 4. You should get 2 times 8 permutation 4. You should get 3360. 3360. What is the total number of arrangements of 6 books chosen from 10 books in which the comic book and fantasy book are placed side by side? So comic book, fantasy book, 3, 4, 5, 6. We do 2 times since they can be flipped. Also, since these 2 are fixed, it becomes 8 permutation 4 times the different positions. So 1, 2, 3, 4. So I can see 4 circles and I add 1 to it. So times 5. So 2 times 8 permutation 4 times 5. You should get 16800. Question 5. Mr. Rawlings wants to take a picture of a group of students that consists of 5 girls and 4 boys. He will seat 3 of the 5 girls together in the first row, and to their right he will seat 2 of the 4 boys. The remaining students will be seated in the second row. In how many different ways can the 3 girls and 2 boys be seated in the first row as described? Since there's 5 total of girls, we do 5 permutation 3 times 4 boys, 4 permutation 2. That's it. So we do 5 permutation 3 times 4 permutation 2. You should get 720. Now that says 2 of the students are brother and sister, in how many different ways can the 3 girls and 2 boys be seated in the first row as described if at least one of the 2 siblings has to be included in this row? I don't know if this is possible or not, but if it was possible, it would take a long time, so it's easier to find the complement, which is the total minus none of them together in the same row. So none of them in the same row also. So none of them in the first row. So the total is the number that we found in part A, which is 720, minus, we remove 1 from the girls since we're removing the sister, so it becomes 4 permutation, and we're choosing from the remaining girls with the sister being excluded 3 of them, times 3 boys. We removed the brother and we're choosing, or we're not choosing, but we're taking 2 boys from them, because choosing, it reminds me of combination since it's C for choosing, I think. It just doesn't sound right. So we do 4 permutation 3 times 4 permutation 3 times 3 permutation 2. 720 minus the answer. You should get 576. المهم, regardless of how you say it, you decrease these since you're removing the brother and the sister and you're choosing from the remaining ones, and we're taking the total minusing from none of them, so we can get at least 1 or 2 of the siblings. So this is 720. This is 57576. Okay, bismillah. Alhamdulillah, it's all correct.